Hello everyone, my name is Viraj, and today we'll be looking at the 16th problem from the CP-31 sheet by TLE Eliminators under the 1000 rated questions. Let's go. So moved on to my sheet over here, ticked off 1000, and I'll go to my 16th problem, red versus blue. Let's read this. Team Red and Team Blue competed in a competitive FPS. Their match was streamed around the world. They played a series of N matches. Now in the end, it turned out Team Red won R times and Team Blue won B times. Team Blue was less skilled than Team Red, so B is strictly less than R. Very important point. Now you missed this stream since you overslept, so you think that the match must have been neck to neck. So you imagine a string of length n where the ith character denotes who won the ith match. And you imagine the string such that the maximum number of times a team won in a row was as small as possible. For example, in a series of matches R, B, B, R, 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 B, Team Red won 3 times in a row, which is the maximum. You must find a string satisfying the above conditions. If there are multiple answers, you have to print any. So they are saying they will give you these 3 variables n, R, and B. Now, they want you to print a string S of n size, which will only be made up of letters R, this is capital R, or the letter capital B. How many capital R's should be there in this string? That is equal to the small r, this is number of R's you have, and small b is number of how many B's you have in the string. Okay, fairly simple. For example, if R was 2 and then B was, let's say, 1, then R, R, B. This is a good string, correct? So it's fairly obvious to write that n is R plus B. Okay, I hope this is clear. Now, this string that you print should actually satisfy one very important condition, and that condition is the maximum length of consecutive R's or B's should be the lowest possible. As in, the target is, I'll write it over here, max consecutive, you can say consecutive win or wins of R or B is lowest possible. All right, this is a very small point. If your string satisfies this, it's a plausible answer. You can print that. All right, so let us see the second test case over here, 6, 5, and 1. I have n as 6, R is 5, B is 1. Now in this case, the answer according to them is you print a B like this, and then you can place 3 R's over here, and you can print 2 R's over here. Now, why is this correct and what other answers were wrong, I'll tell you, and you will understand this condition that we were talking about. If you figure out the maximum consecutive win for R, for example, it is 3 because this is 2, this is 3, so 3 is bigger, maximum is 3. And if you figure this out for B, it is only 1. So you can say that R consecutive max wins is 3, B's consecutive max win is 1. Out of this, what is the bigger? As I said, I want either of R, either of B, so it's 3. So if I ask you that the maximum consecutive win of this string is coming out of 3, that is correct. But why is this string the best? Let's take a different example. Let's say the string would have looked something like this. I would have placed 4 R's on one side and then this B and then this R. Now this has still 5 R's, 1 B, but the placement is different. The placement has now 4 R's consecutive, 1 R and 1 B. Now in this case, this 4 is what dominates. So if I ask you what's the maximum consecutive wins in this, you will say 4. Now remember, you wanted to make the maximum consecutive wins of either R or B to be the lowest possible. The previous string that we had, where B was over here and R was over here, and you had 3 R's in the front, your answer came out to be 3. But over here, the answer will come out to be 4. Which is better? You want the maximum consecutive to go as low as possible. So don't you think this is an answer that you would have taken, not the above one? Yes, that makes sense. Okay, so very, very simple problem. You must have seen problems like this previously also. If you look at the other cases also and you just try to judge their output, you will again understand why is this making sense. Let's say 7, 4, and 3, the answer looks like this. In this test case, it's very clear that the maximum consecutive win for B or R, when you take the max of that, is 1. And I think 1 is the lowest we can create. Anything below 1 is not possible. Hence, this is a viable answer. Similarly, for this case, they actually printed something that looks like this. In this, I can clearly see that R is coming 2 times consecutively. So I think 2 is the answer for that. And you cannot do anything better than 2. You might have been able to do above than 2. But again, as I said, we want to minimize. So we went ahead with this sort of string. And in this, you can actually see that you have 13 R's and 6 B's. If you count that, you will understand that. Okay, so fairly simple problem. You can go ahead and see the next input part also. They have 6 test cases and maybe try to figure out some logic so as to see why is this output making sense. And I think you will be able to come up with some approach. Great. So the problem is clear. Our aim should be clear. The test cases are done. Let's talk about time complexity. We know that one test is allowing me 1 second. And in one test, there are some test cases that is in 1000 order. So that means I can write something like this. One test allows me 1 second means 10 power 8 operations. If I write the number of operations for every test case, that is going to be 10 power 8 upon 10 power 3. That is 10 power 5 operations. So on an average, 10 power 5 is what is allowed. Now n is given over here in 100 order, and r and b both sum up to n. So you know that their maximum also going to be in 100 order. 100 means 10 power 2 order. 10 power 2 is actually not very large. So if I say that n is in 100 order, if I create some sort of a linear solution, O of n, does this work? It does. If I create something like n square, it still works. But as soon as I go in some sort of a cubic order, that's going to be a problem. If I come down and create something like a constant solution, that is all fine. So I know that solutions till square order are looking good to me, but as soon as I go in cubic, they are not right. Now this is a general thing. This is my expected time complexity discussion, which is very helpful because now if I actually start creating my solution, I know that I have a limit to go to n square, which might indicate a brute solution. It might not be compulsory, it might not actually happen, but still you have a margin. It's always best to know of a margin. Now let us start solving the problem. So let's try to note down some very simple points that we already know. We are looking to make the max consecutive wins the minimum. Now the second point that I know from the problem itself is r is greater than b. Let me ask you a very simple question. Imagine that all the r's come together. Do you think it will be fruitful to bring all the r's together? I don't think so. Go back to the test cases. See over here. Let's say you had 4 r's, you had 5 r's, you had 13 r's. If you bring all of them together or in consecutive manner, that creates a case which is very bad. Compared to what the answer is given, it's definitely not working out. So I know that just by looking at the cases, it should be intuitive. I am looking to maybe distribute the r's. I'm not trying to make the r's come consecutive. I'm trying to make them come in small groups. Now, when you understand this intuition, the next question you will ask yourself is, okay, if I'm trying to make them come in small groups, what actually bifurcates a group from each other? And this is where you will see that voila, you have been given B. So you can imagine our method of distributing these R's is basically trying to create groups or regions which are separated by B letter. Let's take an example. So I have R as 12, for example, B is 3. So what I'll do is I'll place these 3 B's like this. And in between them, I know that there is space of a region. I'll mark that with green. This is a region, this is a region, this is a region, this is a region. Now, is it fairly obvious to say that if you have B as 3, you created 4 regions? Which means if I generalize this, you can say that the region count is B plus 1. If you have B number of that blues, then you basically end up creating B plus 1 number of regions. Now, what happens in a simple region? If you still don't have an intuition, follow with me. Let's not keep this very complex. Let's try to follow a simple simulation. You have 12 R's, count with me. You place an R over here. The first region's R count goes up. Oh, I need to balance it out. I'll place an R, I'll place an R, I'll place an R. Wow, now the number of R's have gone down to 8 and all the regions have same number of R's. This greedily makes sense because now there is no disparity. Everything is balanced and the max consecutive wins for R is 1 everywhere. Okay, let's do something more. Place an R, place an R, place an R, place an R. Okay, the number has now gone down to 4. I have used up 8 R's and the maximum consecutive wins for R is now 2. Still good to go. It's balanced out. I hope this intuition makes sense. Next time I'll say take an R, take an R, take an R, and take an R, and this goes to 0. So I actually end up placing R upon B plus 1 number of R's in a specific region. R in this case was 12, B plus 1 was 4. So I ended up placing 3 R's in these regions. And this is the best case possible because by this method in a specific region, The number of R's in all regions is same. If I would have picked up any one R from a region and made it go to some other region, then that region's value would have turned to be 4, which increases the maximum consecutive number of R's. And I don't want that. I want to minimize the consecutive wins. So I know that this is the best case. Now, this is the most important part. If you don't understand this, pause the video and try to pick up a lot of these cases that we had over here and try to see for yourself. Am I saying right? Is this distribution making sense? Okay. Now, there is a small addition to this sort of distribution. I actually have taken a case where I was able to equally distribute the number of R's in all the regions. But it might not be compulsory always. See, I'll take an example. Right now, I said that I had B plus 1 regions. Okay, I had B plus 1 regions. And I had R number of those capital R's that I had to place. Now, if I was equally able to distribute the capital R's in this B plus 1 regions, that basically meant that I was taking a specific case where R mod B plus 1 was actually equal to 0. That means the number of R's were fully divisible in this B plus 1 regions. The last example was one of them. 12 mod 4 was 0. That meant equal division. But let's say the case number 2 would have said that R mod B plus 1 is not equal to 0. How do you handle this case? How do you greedily still make sure that the maximum consecutive wins of R is the minimum possible? Let's see this example once more. What I've done is I've taken B equals to 3, same thing, but now R is 14. It's not 12, so it won't divide. If B is 3, then regions are basically 4. Very clearly shown, 4 regions. Now let's place 3333 R's that was still with us. We knew that was going to happen as we depicted in the last case. You had R, 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 then you had R, 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 you had R, 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 and you had R, R, R. Now your R's will be left with 2, correct? You can of course find this by simply calculating 14 mod 4, which would have given you 2. Now you have some extra number of R's. You have 2 R's. How do you handle them? I know that this extra number of R's will not cross the number of regions. So I can smartly place 1 extra R in all these regions so that I am balanced out. See, I can have an R over here and I can have an R over here. Simply, this number now goes down to 0. And now the maximum consecutive R's has just upped itself from 3 to 4. I know I could have not avoided going to 4. Why? Because you already had the maximum consecutive regions as 3. Now, if you will add one more R anywhere, you had to go to 4. But then I did not go above 4. I could have maybe placed an R from here over here. Now this had 5 R's and other had 3, 3, 3. So the maximum would have turned to be 5. But no, I greedily made sure that if I reached 4, I still remain in 4. And how do I do that? I made sure by placing equal R's everywhere. So if I had 2 extra R's, 1 R here, 1 R here. If I had 3 R's, then I would have placed 1 R, 1 R, and then 1 R over here. If I had 4 R's, then I would have placed 1, 1, 1, 1, and the last R over here, and so on, so on, so on. So I used those extra R's very smartly, and I made sure my answer does not increase. Okay, so this is the correct idea. Let's actually see this in motion on one of the cases only. You had 10, 8, 2. So I'll actually take this, and you will actually see that yes, our answer works out. N was given 10, R was given 8, and B was given 2. Now, if B is 2, that means there are 3 regions. Very obvious. We can say you had B, B, and then they have 3 regions. Okay. Now, let's calculate what we wanted. First, let's calculate R mod B plus 1. That means you have 8 mod 3, which gives you 2. And if you calculate R by B plus 1, that would be 8 by 3. That is 2 point something, but you can round it down to 2. Now, what does these 2 values tell us? This 2 tells us that right now you will have to place 2 R's everywhere in a region. So let's place them R, 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 R. And then this R tells us that after you have placed equal number of R's in these regions, these are the R's that will be left, extra R's that are there. And you can clearly see, yes, I used up 6 R's, I will have 2 R's left. How do I use them? Just place 1, R in all the regions. R, R, over. So now your string looks like this. 3 R's, then a B, 3 R's, then a B, and then 2 R's. And if you go back, yes, this is actually what matches with our answer. And this is the best case because the maximum number of consecutive wins in this string is 3. And I can guarantee you, you sit with a pen and copy, you cannot do an answer better than this. And anything besides this might actually give you a maximum consecutive in value more than 3, which is not right. We wanted to minimize that. Okay, so this is the problem. It's very implementation and greedy based. To be specific, this idea is also called as pigeonhole principle. Okay, pigeonhole principle. Pigeonhole principle is something that basically tells us that if you have the pigeon count more than the number of holes, then at least one hole will have more than one pigeon. That is this principle. Now, why is this principle visible over here? Because you can see that you had b plus 1 holes or b plus 1 regions, and everywhere you started placing r's. So you actually landed up with at least one region which has more than the equal distribution. You can see that the equal distribution was actually 2 r's, but then you actually landed up with at least more than one region which had more than those equivalent number of r's. So this makes sense. This is like a strong form of pigeonhole principle. Again, for all the beginners, don't get scared. This is just an extra relation that I gave over here. Even if you don't know pigeonhole principle, this problem can be solved. So now that the problem is clear, I have also shown you a test case working on that. You can pause the video and actually run this idea on all the other cases, and you will see that the string that you form actually lands up with the best answer. Let's discuss a pseudo idea now of how do we form the string. First, I need to figure out one region's length. Initially, one region's length without those extra r's can be simply written as r upon b plus 1 flowed down. Let's call this length of red region. And then the extra r's that I will be left with will be r mod b plus 1. Okay, this is extra r. So now what I can do is I can run a very simple for loop. How many times? I can run that for loop b plus 1 number of times, because I'm basically looking to print b plus 1 regions. So I'll write something like this. For loop, let's say times is equal to 1. How many times do I want it to run? B plus 1 time. Okay. Now what do I do inside this for loop? Initially, you want to print the length of the red. So you can have another for loop inside this, which will print r. How many number of times? The length of red number of times. Okay, so this will be some sort of a loop which is like length of red, and you print an r. Now after you do this, you are right now in a region. In that region, do you want to print an extra r? How do you check that? You already have this extra r value with you, extra red value with you. So you can be like, okay, if I have some extra r with me, extra red with me greater than 0, then I'll print one more r, and then this extra thing goes minus minus. Okay. And then finally after this, you want to print a B because one region is complete. So now there is a B, that is the, you can say, bifurcation from one region to another region. But very small point, if you go back in the case, if you actually run a loop in B plus 1 times, are you printing B plus 1 B's? No, you're printing only B B's or B, small b number of B's. So that means you need another if check over here, light if check, that if this times value, okay, is not equal to B plus 1, then you would want to print a B. Because as soon as it becomes equal to b plus 1, that last time you don't want to be. And this is the pseudocode. Now this will actually land up printing exactly what you need, which is a simple pattern. All right, so let us discuss the coding part. It's the same thing that I did in the pseudo structure also. You have the test case variable. You take n, r, and b. Then the string s, this is the answer that I'm trying to create. Length of r, that is r upon b plus 1, length of red rather. Extra red, that is in one region, the extra 1, 1, 1 reds that you place are mod b plus 1. Then times loop 1 to b plus 1. Inside that, a for loop which has for a single region, how many r's do you concat to s? And then you have extra r's left, then you concat one more r, and then you make extra red minus minus. Then if the times is not equal to b plus 1, this is a place where you want one more capital B, so you make sure s is concatenated with that. And when you come out of this for loop, you are ready with your pattern, you are ready with your answer. So you print that simply, and that's your good to go case. Now, what is the time complexity? A bit tricky. You might think it's some sort of a square order. No, the outer loop is running in b plus 1 order. The inner loop is running in r upon b plus 1 order because that is length of red. So you can imagine that this is like b plus 1 into r upon b plus 1. Denominator, numerator cancelled. This is O of r order. R is dependent on n. So n was in 100, that means time complexity is in O of 100 order, which is good to go. I know this works. And space, this is a little extra. I took an extra string to print. If you would have directly printed R, R, R and B wherever you wanted, this space will not be of 100, this will be constant. But it's fine. We know that this is still good to go. And now if you have understood the whole code, you will realize that this is implementation greedy and simple pattern printing. If you're good in all these three fronts, probably this problem is a cakewalk for you. Okay, so that is all that is there in this problem. I hope you like the video. Thank you for watching.